So, lesson 5, projectile motion, part 1. We're going to actually be spending 3 lessons on this. Part 1, part 2, and then yucky weird ones, one of which will be on your test. Welcome to Physics 12. Projectile is an object in free fall. Now, for the purposes of Physics 12, we're going to ignore air resistance. We've already studied one-dimensional projectiles. You do that in Physics 11 all the time. You drop stuff. Now that we've learned vectors, we can study two-dimensional projectiles. First question. A mass is held at shoulder level and fired horizontally. Kind of like this. Okay? Oh, like this. Which curve best shows the path that it follows to the ground? Path A, path B, path C, and path D. And defend your answer. Once again, we're going to vote. Once again, how high you hold your hand is how sure you are of the answer. Positive? Kind of sure? Only voting because Duke's got a Nerf gun and it's cocked and loaded. And he'll shoot me if I don't vote at all. Okay? Which of those paths seems the best? Who says path A? No one. Who says path B? Many. Who says path C? Some. Who says path D? No one. So it's between B and C, one of which is wrong. So you can either defend your answer or you can attack someone else's answer as being wrong. Defend or attack, convince me. Chase, was that a hand up? Yep. As soon as an object is in free fall, it starts to fall. You cannot convince people of that, though, with a rifle bullet. They want to assume that rifle bullets travel in a straight line. No, rifle bullets fall as soon as they leave the barrel of the gun as well. They don't travel straight. They travel in an arc. It's just they're going so fast, it looks like a straight line to us because the curve is so gradual because they're moving to the right so fast, or to the left. They're moving horizontally so fast. B is correct. A lot of people think it's C, that somehow we have some momentum and it keeps going straight and then suddenly gravity starts to yank on it. Nope. Nope. As soon as you are in free fall, gravity is pulling you down. And what I really want you to realize, Rob, is the horizontal velocity is completely independent of the vertical velocity and acceleration. You can completely, Alejandro, separate them. Treat them as complete separates. So defend your answer. Gravity pulls right away. D, that's Roadrunner physics, right? If you ever watched the old cartoons, they would run off the cliff, keep going straight, then they would realize that they'd run off the cliff, look down, and then he would fall. Yeah, it's Roadrunner physics. A, that's if you're dropping something, but not if it has any kind of horizontal velocity. So, what does that mean? Well, example 2. Suppose we had 2 identical objects which are held at the same height above the ground. Object 1 is released and it falls to the ground. Simultaneously, object 2 is projected to the right and it also falls to the ground. Which one hits the ground first? Object 1 because it has a more direct path. Object 2 because it's moving faster than object 1. Or they both hit at the same time. Once again, we're going to vote. Once again, how high you hold your hand is how sure you are of the answer. Okay? So we're using our imaginations here. I think I have a video demonstrating this, but first we're going to try and just visualize. So we're dropping an object as well as shooting an object straight sideways. Which one hits the ground first? A or B, or they both hit at the same time? Who says A? Who says B? Who says C? Was that peer pressure, or are you good physicists? Convince me.
All the same, right?
Both fall vertically at negative 9.8 meters per second squared. They both have an initial vertical velocity of 0. And I think I have a video demonstrating this. Give me a second here. What we really want you to realize is that the horizontal and vertical motions of a projectile are independent. This means that what happens horizontally does not affect what happens vertically. In this demonstration, both of the masses have the same vertical motion, and so they hit the ground at the same time. And the horizontal has no effect on the vertical. In fact, if you look at a stop action or a strobe picture of a projectile, you would find that it was moving at a constant horizontal speed, but its vertical speed is not constant. If you looked at dropping an object and at the same time you shot another object sideways and you strobed the photos every 1/10 of a second, you would see something like this. You would see horizontally it was traveling the same distance, vertically it was falling further. Why? Horizontally, what's the acceleration? Do you remember? 0. Vertically, what's the acceleration? Okay. Vx is constant. That means that, turn the page, Ax is 0. By the way, my abbreviations for horizontal and vertical, how about X and Y? Nice, Emily, concise, easy, and clear. And Vy changes because Ay, although it's constant, it's not 0. It's negative 9.8 meters per second squared. Alejandro, it says give reasons for your answer. I think I just did. Sure, there's the argument. As long as, Sam, we ignore air resistance, and we're going to in our magic physics world. Air resistance, you really need calculus to do it well. You need drag coefficients and all sorts of stuff. So it says, consider the stop motion path of the picture below. At each point, indicate the velocity components, what happens at the top, what can be said about the projectile when it's just about to hit the ground. So I've given you an example. I've said if we launch at an angle, we can think of it as traveling horizontally and vertically. Which of those components is never going to change? So if I wanted to, I could draw a vector the same length there, 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 and there. I'll do the vertical component in red. On the way up, what happens to the vertical velocity? I think it's slowing down, isn't it? It's on its way up, so it's slowing down vertically, yes? So I'll draw the vertical component a little shorter here than the original one. What would the vertical component be at the very, very top for a split second there? 0. And then now it starts to come down, so there'd be a little vertical component heading down, and when I hit the ground, there'd be, well, what can you say about this here and this here? What can be said about the projectile when it's just about to hit the ground? This is negative initial velocity. Same magnitude, opposite direction. So if you launch at 40 meters per second at an angle of 30 degrees above the horizontal, you'll come back down at 40 meters per second at an angle of 30 degrees below the horizontal. We say, Brett, what goes up must come down. Really, that's where the expression comes from. Okay? So what happens at the top? What can be said when you're just about to hit the ground? The final velocity equals negative the initial velocity, where I'm talking about both velocities combined together as well as the vertical components. That's, Zach, if you're starting and ending at the same height. And you did that last year, ground to ground. This year, we're often going to be going over a cliff. Oh, if you go over a cliff, do you hit the ground at the same speed as you launch? No, because you've fallen further. You've been able to speed up further and further and further and further and further. When you hit the ground, you're going faster. That's why if you jump off of a cliff, you die. See, otherwise, you would end up coming back at the same speed as you left the cliff at. You'd be just fine. Never thought of that, yeah. Example 5 says, indicate velocity components on this stop action picture. Fill in the key facts about two-dimensional projectile motion. Okay? So Here's our v. We would break this up into Vx and Vy. At the very, very top, what can you tell me about any of those things? Or can you tell me anything about any of those things? I think Vy equals 0. Are you telling me it's no longer moving horizontally, that it's just frozen up there, hanging up there in space? No, no. At the top, though, Vx still equals Vx. It hasn't changed yet. What about when you get back to the same height as you launched from? What can you tell me? Well, Vx still equals Vx. There's no horizontal acceleration, so Vx is Vx is Vx is Vx is Vx. My initial vertical velocity that I launched at, I'll put a little I right there. There's my initial vertical velocity. That's equal to negative Vy right here. I won't call it my final velocity because I'm still following Ashcan. And in fact, my Vy final now is going to get bigger and bigger and bigger. Negative, but bigger and 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 bigger until splat. In fact, just before impact, Vx still equals Vx, but Vy final is not equal to Vy initial. It's way bigger, but negative. We usually won't put a negative in front, Nico. Instead, we'll just draw a vector arrow pointing down, and that'll take care of the sign for us. Horizontal speed is constant. Why? Yep. Duick, you're really doing a big song and dance about if you wrap your brain around this, then everything I teach you for the next few days will make sense. You may not have thought of it, but oh yeah, okay, now that you've gone with that, yeah, that fits in. Vertical speed is not constant, it's changing. Why? Yep. By the way, is the vertical acceleration changing, Ashcan? No. So vertical acceleration is constant. Velocity isn't. The reason I say that is sometimes when I say horizontal speed is constant and then I say and vertical acceleration is constant, people no, that means that it's not changing. No, the acceleration isn't changing vertically. It's negative 9.8. As long as you're close to the Earth, within a few miles of the Earth. We will later on start looking at outer space. And in outer space, because you're further from the Earth, acceleration changes.
What if there was a question that said it accelerated at a horizontal speed?
First of all, if it's a projectile, it couldn't. It would have to be some kind of a rocket or something that had an external force that was causing it to accelerate. It would have to have an engine or something, or little invisible angels were pulling it along. Something would have to be happening. Okay? Horizontal and vertical motions are independent of each other. Good question. All right. Let's start analyzing some of these. It says, fill in the chart describing the horizontal and vertical motion of the projectile below. Indicate correct signs, positive and negative where necessary. So we're launching from a 50-meter high cliff. We're launching dead horizontal. So you did do this last year, I believe. Last year you went at an angle from the ground back to the ground, horizontally from a cliff. This year what we're going to add is at an angle from a cliff and then going backwards. What if I tell you where you landed? Can you tell me how high you took off from? Or what if I want to know you're not hitting the ground, I'm going to tell you you're going to run into a wall. What angle will you hit the wall at? So nastier stuff, but it's all based on this. Whenever I'm doing a projectile question, I always draw a line down the middle of the page to divide it into horizontal and vertical. Conveniently, that's been done already. And the first thing that I almost always write is I would put an AX equals 0 and an AY equals negative 9.8. Because those aren't going to change. Also, because now I've written something down, I feel better. What else do I know? Do I know my initial horizontal velocity according to this question? Yeah, what? 20. Do I know my initial vertical velocity according to this question? Yeah. What? Careful. 0, because for a split second, right when you leave the cliff, you haven't quite had a chance to start free fall. You start free falling immediately after leaving the cliff, but your initial vertical velocity is 0. This is not enough. You cannot solve any projectile question with only 2 pieces of information in either column. You're always going to need a third one. If you're lucky, Emily, they've told you the time of flight. If they tell you the time of flight, this falls apart. Or they're going to give you a displacement. They're either going to give you a horizontal displacement or a vertical displacement. Look at the diagram. Have they given me a horizontal displacement or have they given me a vertical displacement? Vertical? What's my vertical displacement? Careful, it's not 50. Page.
Negative 50.
Why negative?
Because displacement or distance, and it's below where
I end up below from where I started from. I have to call it negative 50 meters. If I get that, I can now start to solve this. So example 7 says, use the values of example 5 to find the flight time and the range of the projectile. All right, so we already said this was 20, this was 0, this was 0, this was negative 9.8, and this was negative 50. You'll notice in one of those columns, I now know 3 things. Which column do I know 3 things in? Vertical, that means I'm going to solve this for t vertically. If I knew 3 things in the horizontal, I would solve for t horizontally. We're going to go vertical, and I'm going to write down t equals question mark. And now I've dulped and I've deficked. And I'm going to say, I know VI, A, D, and T. Is there an equation that has D, VI, A, and T in it? There is. You're right, whoever murmured it there. And I'm going to be fussy now. I want to avoid making sloppy vector mistakes. So I'm going to, since I'm doing this vertically, I'm going to go dy equals vy initial t plus 1/2 ay t squared. You don't have to, but I'm just paranoid I'll put the wrong stuff in the wrong stuff. And so, Joe, this helps me keep a little focused. Oh! Why can't I do this? Yoink. Oh, that's nice. Whoops. I hit the erase button. That was a mistake. Whoops. That was a mistake, too. This pen is driving me crazy. It's got an erase button on the side, which I'm not used to having. So what are we trying to find, Brett? Let's get the t by itself. I think I would times by 2, divide by a, and then how do I get rid of a squared, Cole? You know what? I think t, let's see if we can do this in one step. T is going to be the square root of 2 dy divided by ay. That's an A, Mr. Duick. Looks like a 9. I'm going to get 2 times negative 50 divided by negative 9.8. Do I have a negative on top and a negative on the bottom? What is a negative divided by a negative? Well, that's good because I can't take the square root of a negative. That's also a built-in error check. If you forgot to include the negative 50 for your displacement, you'd get an error on your calculator on this line here. For big square roots, I generally type what's inside the square root first, like this, and then I go square root answer button. And I get a time of flight of 3.19 seconds. And since that's an answer they wanted me to find, I'll put a box or something around it, also because I'm going to use it. That was the first thing they wanted me to find. What else did they want me to find? The range, the horizontal displacement, which we call the range. So now I'm going to go walk over here, and I'm going to say dx equals question mark. But Zach, I now know one more thing. What else can I put on this left? Because right now, with only two things, I can't solve it. What else can I put on this left-hand column now? I can say that time equals 3.19 seconds. So, Zach, I'm looking for an equation that has d, vi, a, and t in it. I'll give you a hint. It's the same one. Except in this case, what's 0 on the horizontal side? So you're going to get this, VIT plus a half AT squared, except that's going to vanish. In fact, you're going to get dx equals VXT. It's going to be 20. Now, I'm going to write 3.19, but I'll use this stored value that's still on my calculator. Why not? Times 20. And I get 2 or 3 sig figs for my final answer. 64. I'll go 63.9 meters. Okay.
Is that where we ended up at?
That's how far away from the cliff, the base of the cliff, you landed and hit the ground at. So that's from a cliff horizontally. In some ways, it's got a nice advantage because you have a 0 initial velocity for the vertical, which makes the equations way nicer. You got lots of zeros kicking around. Example 8. At an angle from the ground. What do we do if we're at an angle from the ground? The answer is we don't deal with it. We break it into components. I'm traveling at 100 meters per second at an angle of 35 degrees. I am not going to use that 100 to solve anything. I'm going to break that 100 into its components, and I'm never going to use it again because nothing that I have is at an angle. My accelerations are all vertical or horizontal, so I'm going to break it up into components. How am I going to do that? There's Vx. There's Vy initial. How come I didn't put an initial on the x? How come I only put an initial on the y? Yeah, you know what? I'm reminding myself Vx isn't going to change, so who cares? Vx initial is Vx final, is Vx in the middle. That's Vx. The vertical is going to change. I'll remind myself of that. Here's my angle. Opposite, hypotenuse, adjacent. Let's find, well, what do you want to find first, Cole? Vertical or horizontal? I don't care. Okay, which trig function? Sine. Sine of 35 equals Vy initial over 100. In fact, I'm pretty sure, Cole, Vy initial is going to be 100 sine 35, which is 100 sine 35. 57 point. Well, you know what? This is not an answer they asked me to find, is it? So I'm going to carry a few extra sig figs here because it's not a final answer. I'm going to go 57.36, I think. Because I'm going to be using this to find other answers. So I'll carry a few extra sig figs. Hey, Cole, which trig function is Vx going to be? Which trig function is Vx going to be? Give you a hint, not sine. Tan would work, but then I'd be using Vy to find it, which means I might make, I'd use cosine and use the 100. In fact, if you have a really good calculator, you should be able to just go backspace and change the sign to a cos. Isn't that cool? And I get 81.92. meters per second. Meters per second. Mr. Dewick, are you fussy on units in the work? Nope. Your final answer, I'm very fussy about units. I'll always take marks off if you don't include the units. So if I'm solving a projectile, I'll always divide my screen in half. Hey, I already have. I would label this as, first things I would write down, AX is 0, AY is negative 9.8, because that's never going to change. And now I've written something down, Rob, I feel better. It's no longer blank. Oh, and I also know that VX is 81.92 and VY is 57.36. Example 9, they want me to take this information and they want me to find time to top, total flight time, and range. I'll quickly drop this information down. It was 0, it was negative 9.8, it was 81.92, it was 57.36. I need more information before I can solve this, because with two things, I'm stuck. What's the first thing you want me to find, Sam? Okay, let's do that right here. I know one more thing at the top. This is my third piece of information. You know what I know at the top? Which one? Vertical velocity, don't I? What's my vertical velocity for a split second at the top? At the top for a split second? Right. Vy final is 0. Hey, I now have 3 pieces of information. Means I can find the fourth. Is there an equation that has A, Vi, Vf, and T in it? There is. Which one? Some of you really need to have your formula sheets out. And do me a favor, can you get the T by itself when you read it to me, please? Something with A, Vi, Vf, and T. Got it? And get the T by itself. T equals Vf minus Vi all over A. Oh, this is great plug and chug. This isn't even a quadratic with a square root or anything. This is 0 minus 57.36 divided by negative 9.8. And since this is a final answer, I will go to 2 or 3 sig figs. 0 minus 57.36, close bracket, divided by negative 9.8. 5.85 seconds, sounds good. What does B want me to find? Total flight time. How can I find total flight time? Because I'm ending up back where I started from, and that's an important distinction, I can just take time to top and double it. You know why, Brett? Because what goes up must come. Oh, yeah, there's some good physics in that statement, actually, as it turns out. So now, I might hedge my bets a bit because I'm using my answer from A to find B, which, Courtney, means if I got A wrong, I'm getting B wrong. Although I would give you full marks on B for doing this because you're doing a good method. Even if you got the wrong answer in A, I would say, well, you doubled the time. That's good. There is another way, but first of all, let's get an answer. 11.7. You do know one more piece of information. And what you know is your vertical displacement. How high were you when you started? No, how high was your height when you started? 0. What's your height when you're finished? What's your vertical displacement that you've traveled then? 0, which is counterintuitive. No, no, we went up and down. No, no, that's distance, displacement. You could actually say dy is 0, and now you have an entirely different equation you can start whittling away at too. C. What does C want me to find? Range. Range, vertical or horizontal? Let's go horizontal then. dx equals question mark. I'll put a letter C here. Except in this column right now, in my horizontal section, I only have 3 things. That's not enough. Ah, but Zach, there is one more thing that I know. What? Which time am I going to use? Total time of flight. Is there an equation that has acceleration, velocity, time, and displacement in it? There is. As a matter of fact, it's the d equals vit plus a half at squared, except what's a equal to? Horizontally, it's 0. In fact, you can really just say this. Horizontal displacement, or range, is horizontal speed times time, because a is 0. It's going to be 81.92 times 11.7. Conveniently, I have this number still stored on my calculator, so I'm just going to go times 81.92, and I get 959, because this is a final answer. I'll go to 2 or 3 sig figs. Yes, I'd also take 960, but 959 meters. Wow, almost a kilometer. That's a chunk of distance. In theory, Austin, you did that last year. Turn the page. Question? Range is by definition horizontal. What's the range of a projectile? You're really saying how far is it traveling along the ground? It's an artillery shell term. If you've ever watched old World War II movie or old movies and they're using artillery, you may even hear them say, range, 119 meters. Range to target, what they're really saying is how far away is it? We're going to launch and land. All right, Physics 12 time. Sam, off a cliff at an angle. We couldn't really do this last year because last year we couldn't be sure that all of you had seen the quadratic formula. You are going to use the quadratic formula for this. Sorry, you can, if you want to, because it's quicker, use the quadratic formula for this, which is on your formula sheet, and I did review solving a quadratic. There is also a way to do this without using quadratic equations. I'll show you both. There are 3 methods if you want to analyze from a cliff. The first method says, find how long it takes to get to the top. Then, assuming your initial velocity is now 0 because you're dropping from here, find how long it takes to get to the bottom. Add the times up. Works just fine. I'll give you full marks. The second method, do the whole thing at once. Find the total time in one fell swoop. The third method, which I don't recommend, find how long it takes to get to the top. Double it to get to the top, back to the cliff height. And then you know your final velocity when you get to cliff level. It's the same as your initial vertical velocity, but negative. You can make that VI over here, and you can have A equals negative 9.8 and the displacement and solve for T. I'm not recommending because that's finding 3 different times and adding them together. In fact, Akemi, I really prefer strategy 2. Strategy 2 is going to require you to use the quadratic equation. X equals negative b plus or minus the square root squared minus 4ac over 2a. Suck it up. Oh no, some of you might even have solvers and things, and I'm totally good with you using that. If you're really having issues with a quadratic equation, I will show you a way to do this without using quadratics. It's in 3 steps, but it's cleaner than strategy 3. Example 10, find the flight time. You have to notice here, Kevin, that we're launching off a cliff at an angle. And if you see that, you should be going, whew, okay. ramping up your game. We are at an angle. We're going to start out the same way. We're going to break this up, Sam, into components. Brian, what do you want to find first, vertical or horizontal? Doesn't matter. Sorry? Okay, which trig function? I think this one works out dead even to 25, I think, yes? Brian, which trig function for horizontal?
Cosine.
I agree. .3, even to 4 sig figs, it's still 43.3. In fact, it's 0.301, so I'll just go 43.3. That's pretty good. I do that first. Now I'm going to plan my attack. Draw a line down the middle of my page. Horizontal and vertical. Oh, and right away I'm going to say, and I know horizontal acceleration is nothing, and I know vertical acceleration is negative 9.8, unless I'm not on this planet. Oh, I know two more things, what we just did in red up above there. I know Vy initial is 25 even, and I know Vx is 43.3. This is not enough. I know one more thing. From the diagram, dy is negative 60. Which column do I have three things in? Vertical. How am I going to solve for time? Vertically. In fact, I'm going to write t equals question mark. By the way, finding the time to the top is pretty easy. We're going to be using about this much room to do the vertical one, so if you want to do something like that, you can. We only need a little bit of room to find the time to the top. Hey, I need an equation that has a, v, d, and t in it. Which one? D equals VIT plus a half AT squared. Are any of these 0 this time? Nope. See, if one of these was 0, I can get the t by itself using grade 8 math. But since nothing is 0, I have a t and a t squared. I can't get it by itself. All I can start to do right now is plug and chug numbers. I can say negative 60 equals 25t minus 4.9 t squared. Where'd the minus 4.9 come from? I did half of 9.8 in my head because I've done it so often. What kind of an equation is this? It's a quadratic. How do I know? Oh, do it, because that what that little slung and down? Yeah, it's got a squared. How am I going to solve this? I got to make it equal to 0. This ain't going to factor. It's going to be the quadratic formula. The easiest way to make this equal to 0 would be to plus the 60 over, except from personal experience, I make dumb mistakes when the quadratic term has a negative in front of it. So I'm actually, Brett, going to move the 4.9 over to make it t squared to make it positive, and I'm going to minus the 25t. It's a preference, Alejandro. It's not wrong to plus the 60 over. It's less work. But I know I just make dumb mistakes when my squared term has a negative in front of it. So I'm going to rewrite it like this. Positive 4.9t squared minus 25t minus 60 equals 0. And I'm going to write the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Mr. Dewick, you're not solving for x, you're solving for t. Yeah, actually, I should have put t equals, but I'm not going to take marks off, and I didn't want to scare you. What's a in this quadratic equation? By the way, this is also why I always put a y on my acceleration, because this is a letter A and this is a letter A. Is it possible for you to get them confused? We're running out of letters. We need a bigger alphabet. So AY is acceleration, A is quadratic formula. What's A in this quadratic equation? 4.9? What's B? Negative 25. What's C? Now, if some of you have a built-in quadratic solver, and I tried to show those of you that do, you can now go straight to the answer. If you write this much, I have to assume that you actually carefully put the numbers in, and you actually did the arithmetic, and you actually did it properly. If you say right now t equals negative whatever and positive whatever, you get full marks. How many of you don't have a quadratic solver? Okay. Who's got the graphing calculators? You have one on there probably. If you press the apps button, it's a button right in the middle of your screen somewhere there. And then scroll down, see if you have a program called Polysmlt, P-O-L-Y-S-M-L-T. Run that, and then use the polynomial root solver and see if you can figure it out from there. The rest of us peons, here we go. Negative b. b was negative 25, so negative 25. 25 plus or minus the square root of, you know what? I'm in grade 12. I'm in physics. I'm going to type the b squared minus 4ac on a separate line right now. I'm going to go negative 25 squared minus 4 times negative 4.9 times negative 60. You know, oh, I typed that in wrong. Oh, the 4.9 isn't negative, Mr. Dewick. That's why you plussed it over, so you don't make that mistake. The 60 is negative. Inside the square root, do you get 1,801? Yeah? 1801, a very good year. All divided by, and I can even multiply by 2 in my head, even if it's decimals. I think 4.9 times 2 is 9.8. How many numbers are on the top? 2. I better use brackets when I go to my calculator. Bracket 25 plus the square root of 1801. Close off the square root, close off the top, divided by 9.8. One time I get is 6.88. Those of you with a solver, am I right? Yeah. Another time I get, this is probably going to be the negative one that I ignore, but I'll do it just for consistency. Negative 1.78. Can I have a negative time? Not unless you're Einstein. So the first thing they wanted me to do was find time of flight. There it is. You can see, Akemi, the amount of work went up dramatically. Yep. Great question. Did you hear what Brett asked? Ask it again.
Is the negative time relevant to anything?
Let's suppose instead of traveling 50 meters this way at 30 degrees, it was traveling 50 meters per second that way into the ground, and the ground wasn't there. You know how long it would take for it to hit the ground on the other side? 1.78 seconds. Yeah, it's actually telling you if you started from the ground over here somewhere, you would have needed to travel for 1.78 seconds to get to there and hit that velocity at 50 meters per second at an angle of 30 degrees. So it actually does tell you something. Isn't that kind of nerdly cool? No, shut up. Pardon me?
Is that useful to us at all? Like, will it be in the question? Or
I have to be completely, he asked, is this useful to us at all? I have to be completely honest. I'm fairly sure this whole lesson is useless to you. I have yet to see any one of you who gets a job where you're required to find projectile ranges. You mean on a test?
Yeah.
Nah. Otherwise, I would have included it in the notes. B, find time to top. That's easier, because at the top, I know that. Which means I can go T equals VF minus VI over A. 0 minus, what was my initial vertical? 25 divided by negative 9.8. This is why I said you don't need much room to solve for T over here. Zero minus 25 divided by negative 9.8. 2.55? Anyone else? Yep, people nodding. Seconds. Find the range. Okay. Range, horizontal or vertical? Horizontal. I've turned the page. So I'm going to quickly defic A and 43. Okay. I'm going to quickly write AX is 0. And I'm going to quickly write VX is 43.3. You guys still have it on the same page in front of you, yeah? So you didn't have to rewrite it, but I'm always uncomfortable if I'm trying to scroll back and find data. Oh, I know one more thing now, Zach. What do I know now? Which is what? Which time am I going to use? Careful. The range is just equal to VXT. What happened to the half AT squared? Alejandra, what's A horizontally? 0, which is why the half AT squared gone. VX 43.3, 6.88, 6.88 times 43.3, 298. I agree. Okay. How far are we going to get here? Yep. One more, and we're going to pause. We're going to pick up with this next class. Okay. D, find the impact velocity. Say what? Isn't it 0? No, that's after it hits the ground. The impact velocity, right when it hits the ground. I don't know what it is, but you know what? Nico, I know what it looks like. I'm pretty sure it hits the ground like that. In fact, let's call that V final. Oh, and I'm pretty sure that I can think of that as traveling sideways and down. I could call this Vx, which I know because Vx isn't going to change through this whole question. What's Vx? I think it's traveling sideways when it hits the ground at 43.3. If I can figure out how fast it's traveling downwards when it hits the ground, can't I use Pythagoras to find the magnitude of V final? And then can't I use a bit of trig to find the direction? Because they did ask for velocity, not for speed. Well, what was the initial vertical velocity? I've scrolled down. What was it? 25? And what was the vertical acceleration? And how long was it in the air for? 6.88. Can I find the final velocity with those three things? In fact, for the first time in a long time, I think our equation that we're using actually has the thing by itself already, doesn't it? Isn't there an equation that has V final by itself already? It's going to be V initial plus AT. The final velocity when I hit the ground is going to be 25 plus negative 9.8 times 6.88. What's the final velocity vertically that we hit the ground at? Still traveling horizontally, but vertically, what do we hit the ground at? Give it to me because I'm going to use this. So give it to me like 4 maybe sig figs or
42 or negative 42.42.
Negative 42.42, is that right? Yep. Ashcan, what's the negative telling me? It's going down, which matches my picture. So it's built in a little error check. So I'm not going to put the negative on my diagram, but you're telling me this is 42.42? Hey! I can find Pythagoras. It's going to be 43.3 squared plus 42.42 squared equals square root 60.6 meters per second. And I think the angle is going to be where that vector starts from, right there. How do you know to find the angle, Mr. Dewick? Because they didn't say find the impact speed. Sam, what did they say? Find the impact magnitude and direction vector. Which trig function will I use to find theta? Alejandro. Tan, sure. Opposite, adjacent. It's going to be really close to 45 degrees because both those sides are almost the same length. It's almost an isosceles triangle. Tan theta equals opposite over adjacent. Second function tan of opposite over adjacent. Like I said, it's going to be really close to 45 degrees. At, there's my at symbol, 44.4 degrees. Direction. Folks, look at me for 1 second. That is not north and that is not south. And please don't be calling that north and that south. How would I say this? Here's how we would say this in the physics world. We would say, come on, pen. No, we can't. It's not south. We're going to say below the horizontal. That's not north and south. Don't be calling it that. We're talking, because now we're in our three-dimensional world, we would say below the horizontal. See where theta is? It's below a horizontal line. On its way up, if it was going up still, you'd say above the horizontal. I won't take marks off if you say south of, but I'll kind of look at you like, really? You're telling me that's north? It's not. You're telling me straight down is south? It's not. Not on any maps that I look at. Pause here. Put your pencils down.